Hello folks, we are once again back with the problem number 12 of this miscellaneous exercise, and in this problem number 12, it's a typical problem. We have not done so much of that kind in the earlier part, so let's go over it once again and see what it says. A point on the hypotenuse of the triangle is at a distance of a and b from the sides of the triangle. Show that the minimum length of the hypotenuse is a raised to 2 over 3 plus b raised to 2 over 3 and the whole raised to half. So doesn't look so very comfortable. There's a lot of work that goes with it. So let's directly get away by doing the problem. The first, you have the right triangle ABC. In this right triangle ABC, on the hypotenuse there is a point P whose distance from the respective sides is A and B. That's what is given. So because it is a distance, it will be a perpendicular. So that's how we have marked the perpendicular. Now the point to be noted over here is that PD is parallel to BC. Why? Because you've got a 90 degree here, you've got a 90 degree here. Both these angles, they're corresponding angles. Because corresponding angles are equal, the lines are parallel. Like that, you'll have DP to be parallel to BC, which will help you to do other work. So first, right away, let's observe all that. First, let's introduce. Let triangle ABC have point P on the hypotenuse as shown in the figure. As shown in the figure. Okay, since DP is perpendicular to AB, we have angle ADP to be equal to angle ABE, which makes DP parallel to BC by corresponding angles. Converse. Yeah, so that's how you got it parallel. Now because you've got it parallel, you've got DP parallel to BC, you can have AC as a transversal, and if you could call this angle as theta, so you'll get this angle also as theta. That's going to be a huge thing which is going to help you do your work later. Therefore, angle ADP will be equal to angle ACB, which is equal to theta, say we are assuming. And why we got it? We got it because, and anyhow we have told that it is parallel, so by corresponding angles. Corresponding angles are equal, and that's how you've got them equal. So that's about angle ADP being equal to angle ACB. We've got those two thetas equal. Now let's go to those right triangle and try to get a hypotenuse in terms of the A and B and the theta, and let's see how we can work. They have asked us to find the length of the hypotenuse. So AC, that's what we need to find. So let's see how we can do it. First, let's go to the right triangle. In right triangle ADP, we need AP because we want the length of the hypotenuse, and we have DP, so we should be taking cos theta. So cos theta is going to be DP over AP, or rather it is DP is A and AP we require, so AP is going to be A over cos theta, which is A sec theta. So we have got AP as A sec theta. Simultaneously, we can also talk of in right triangle PEC. We need PC and we know PE. So it is sine which is going to help us. Let's look at sine. Sine theta is going to be PE over PC. PE we know it's B. And PC we require, let it go on the other side. So sine theta will come here. So it will become cosec theta. So both these we have got. Our emphasis is on the length of the hypotenuse because that is what we have to work with. So here the length of the hypotenuse AC is AP plus PC, we all know, which we have got now, A sec theta plus B cosec theta. So since we have to find out the minimum length, that's what they are telling, that find out the hypotenuse, find that the minimum length and so on. So we have to work with the derivative part. So let's take the derivative dAc first with respect to theta. Sec theta derivative is sec theta tan theta, and cosec theta derivative is cosec theta cot theta. Now, since in order to show minimum we will require the second derivative, so let's also find out the second derivative and keep. So a sec theta is a product. Here we'll have to treat it as a product. A sec theta as it is, derivative of tan theta is sec squared theta. A tan theta as it is, derivative of sec theta is sec theta tan theta. And then b cosec theta as it is, but derivative of cot theta is going to be cot theta is cosec squared minus cosec squared theta. So then this will get changed. And keeping b cot theta as it is, derivative of cosec theta is going to be cosec cot. So you're going to get that also will change because again a minus with the cosec cot. This is your second derivative, where that is going to be used only when we check the minimum. Now, since you have already got this, let's go in for the critical point. Let dAc over d theta be equal to 0, which means a sec theta tan theta minus b cosec theta cot theta equal to 0. So that will make a sec theta tan theta to be equal to b cosec theta cot theta. Now, very difficult, cosec, cot, they're all different things. In order to work, it's going to be really difficult. So we will do the working by converting this in terms of sine and cos, so that it will be more simpler. So it's like a sec theta means it's cos theta over cos theta, and sine theta over cos theta for tan, and on the other side it is cosec, so that is sine theta and then cos theta over sine theta. Let's take this on this side, So a sine cube theta, b cos cube theta, tan cube theta. By bringing the cos cube on the side, it's b over a. So, or even if you could take cos on the other side, then your cot cube theta would have been a over b. Yes. So tan theta therefore is going to be b over a and the third root, and cot theta is going to be a over b and the third root, or rather tan theta is going to be b over b raised to 1 over 3 a raised to 1 over 3, cot theta a raised to 1 over 3 b raised to 1 over 3. We may require the squares, so tan squared theta is squaring both sides, raised to 2. So it's going to be b raised to 1, b raised to, or rather cube root of b over a times square. So that's going to be b raised to 2 over 3, a raised to 2 over 3. Similarly, you can get the cot also. Cot squared theta is going to be a raised to 2 over 3, b raised to 2 over 3. We keep all this ready whenever we require. In the later part, it will be very easy for us to substitute. So also, let's, if at all we need a sec, because if you want the length, you require sec and cosec. They have asked you the length, and if you want the length, you will require sec and cosec. And how will you get sec squared theta? It is 1 plus tan squared theta. So with that, in the you know that you will be requiring that. So let's get sec squared theta. We know it's 1 plus tan squared theta. Okay, what is tan squared theta for us? We have already got it. We've got it as b raised to 2 over 3 over a raised to 2 over 3. Let's equalize a raised to, so this is going to be a raised to 2 over 3 plus b raised to 2 over 3 over a raised to 2 over 3. So when we want only sec theta, it's going to be the root of this. So it's going to be a raised to 2 over 3 plus b raised to 2 over 3 square root, and the square root of this. Square root means raised to half. So 2 over 3 times half is going to be only 1 over 3. So it's going to be a raised to 2 over 3 times 1 over 2. It's a lengthy problem, so we'll have to go over on the other side. So sec we have got. I think on the same lines you can get cosec on the same lines, or maybe you can get cosec, or you can actually work it out. Like It's all on one's convenience. Yeah, let's get the cosec theta. Cosec theta, we can work on the same lines and we will be getting a raised to 2, or rather we can get it from there. Yeah, we've got cot, no? So cosec squared theta is 1 plus a raised to 2 over 3 over b raised to 2 over 3 equalizing with b raised to 2 over 3. You're going to get b raised to 2 over 3 plus a raised to 2 over 3 over b raised to 2 over 3. So getting cosec theta is getting the root of it. So b raised to 2 over 3 plus a raised to 2 over 3, the square root, and square root of this. Square root means raised to half, as I told you. So this can become b raised to 1 over 3 because it was b raised to 2 over 3 and square root is half. So that will get cancelled and you're left with b raised to 1 over 3. So you've got both now, sec also, tan also. But before we go to this, we have to also ensure that it is minimum. So also d squared AC over d theta squared has all positive quantities. Why? Quantities. Why? Because since theta is always, because the way you have taken theta, it can never be, it can never be pi by 2, it can never be 0, because then the whole purpose of getting the theta will not be correct. So it cannot be pi by 2, it cannot be 0. So it's a value strictly between 0 and pi by 2. So like that, so see cosec, all that is going to be positive, because it's going to be in the first quadrant. So all these quantities, they are going to be, all the trigonometric part, everything is positive. And A and B, they have told is positive. So the entire right hand side, it's positive. So therefore, has all positive quantities. Since this, therefore, d squared AC over d theta squared is positive, and therefore minima occurs. Okay, we are done. Now just to find the length, they have asked you to find the minimum length of the hypotenuse. So let's now get across doing the minimum length, but before that let me write this L. Therefore AC equal to A sec theta plus B cosec theta. Let's get the value, because we'll sec and cosec theta we have modified and kept. So we can use that and we can try to see what's the minimum length. They have asked us what is a minimum length. So that's going to be our next work, to find out what is the minimum length. So sec theta for us, it is going to be, a raised to 2 over 3 plus b raised to 2 over 3. Where is that? Half, raised to half. Why? Because we had got sec squared and then we wanted sec out of it, and there is a raised to 1 over 3 left. Also here it is b times a raised to 2 over 3 that we get from here. A raised to 2 over 3 plus b raised to 2 over 3, square root of that, over b raised to 1 over 3. Now let's work with this. If you carefully see these both things, amongst both the terms, this raised to half part is common. So right away let's take it out, so that our work will be simplified. A raised to 2 over 3 plus b raised to 2 over 3 whole raised to half we have taken out. So in the first term you are left with a over a raised to 1 over 3, and in the second term b over b raised to 1 over 3, which means it is a raised to 2 over 3 plus b raised to 2 over 3 raised to half, and a raised to 1 minus 1 over 3. That's what we learned in the law of exponents. A raised to m over a raised to n is a raised to m minus n. So that way. So 1 minus 1 over 3, which means it is 2 over 3, because 3 over 3 actually. So that is going to be a raised to 2 over 3 plus b raised to 2 over 3, half of raised to half. This is going to be a raised to 2 over 3 plus b raised to 2 over 3. Now when we carefully look at these two bases, they are one and the same. You know that in exponents, if the bases are same, you can add the exponents. So here the exponent is half and here the exponent is 1. Bases are same, so you can add the exponent. Let's add the exponent. A raised to 2 over 3 plus b raised to 2 over 3 is the base, remains as it is. We can add the exponent 1 plus half. 1 plus half we all know is 2 over 2 plus half, which is 3 over 2. So that is a raised to 2 over 3 plus b raised to 2 over 3 raised to 3 over 2. That's exactly what they have asked us. What do they tell us? They tell us to show that the minimum length of the hypotenuse is this. So that's it. Hence proved. That's about it. Yeah, it's a lengthy problem, but if you do it a little with proper steps, it is not so complicated. So that's how we get across doing it. With the next problem in the next video, we can meet. Thank you.